Welcome, friends. So, we are discussing the AC networks. We have seen different aspects of series network, then we have seen the different aspects of parallel networks. Now, we shall see some more aspects. What it's called resonance. What it's called, it's resonance. So, we have already discussed this network. Series RLC circuit where VR, VL, VC are the three voltage drop across individual elements. So this is the phasor diagram. So this is the the impedance, which is R square plus XL minus XC whole square. Now if by some mean or by some reason if it is XL becomes XC, it can happen. Okay, it can happen. How? You see, XL it is omega L and XC becomes 1 by omega C. So in the low value of omega, its XL is less but XC is high. However, if omega is increasing, then XL start increasing but XC starts falling. So at some point of time of frequency, this XL becomes XC. It can happen. Okay. So when this happens, what will happen? Omega L becomes omega C. So from there we can reduce a expression, that is omega square is equal to 1 by LC. Here we can say F0 is equal to 1 by 2 pi root under LC. So what is resonance? Resonance actually means that when the net reactive component is 0. When the net reactive component is 0, then the circuit is said to be in the resonance condition. When net reactive impedance or reactance is 0, then the circuit is in resonance condition. Now what is the properties of resonance condition? Now whenever this XL and XC are same, then Z becomes R. Z becomes R. That is why I said impedance is minimum. During resonance, impedance is minimum. So due to this fact, current is maximum. Current is maximum and power factor is unity. Quite obviously, because Z is equal to R, so net reactive part is 0. So that is why power factor is unity. The frequency at which this happens, it's called resonance frequency, is given by this formula 1 by 2 pi root under LC. Now the quality factor is another important factor, is that it is the voltage escalation factor. It is given by this formula, that is 1 by R root under L by C. Voltage escalation factor means it is the voltage Q factor is voltage drop across the inductor divided by voltage drop across the resistor. So VL is equal to I into omega L and VR is equal to I into R. So this II gets cancelled because it is a series circuit. So from there, if you substitute this omega naught is equal to root under 1 by LC, root under 1 by LC into L divided by R. So 1 by R, so this will become root under L by C. So from here the quality factor comes 1 by R root under L by C. So these are the few properties of series resonance circuit. Now we have parallel resonance circuit. The same thing. So we are familiar with this phasor diagram. So let me a vertical component and horizontal component. So if this is the vertical component, then this current must be vertical component I coil sin phi, and this horizontal component must be I coil cos phi. So with the net reactive current, is 0. That means IC becomes I coil sin phi. Net reactive current means when this IC becomes exactly equal and opposite to this I coil. So this IC, that is the charging current or capacitor current, becomes exactly equal and opposite to the I coil sin phi. What is IC? So IC becomes V by XC, quite obviously. What is I coil? I coil is equal to V by Z or V by Z coil. And what is sin phi? Sin phi is equal to nothing but X coil by Z coil from the knowledge of the impedance triangle. So this is R, this is X, this is Z. This is R, X, Z. This is phi. So sin phi is equal to X by Z. So that is why it is X coil by Z coil. What is I coil? I coil is nothing but V by Z coil. This impedance, if this impedance is Z coil, then this V by I coil is equal to Z coil. So that is the result. So I coil is equal to V by Z coil, and IC is nothing but V by XC. So if you solve this, then it will become, so V by XC, that is equal to V by Z coil into X coil by Z coil. So V gets cancelled. So Z coil square is equal to X coil into XC. That is written here. So now Z coil is what? R square plus omega square L square. R square plus omega square L square. Now what is X coil? X coil is omega L. What is XC? 1 by omega C. So this will be the result. So if you solve this, so you will get a result of, that is the resonant frequency is given by this formula. Resonant frequency is given by this formula. It's a matter of one more line. Now let us quickly scan through the different properties of parallel resonance circuit. Now in this case, impedance now is maximum. Impedance for parallel resonance circuit is maximum. Since the impedance is maximum, current is minimum. Again, power factor becomes in unity. Why? Because the net reactive current is 0. So the net current flowing through the circuit becomes I coil cos phi, and it stays in phase with voltage. It stays with voltage. So that is why power factor is unity. The resonant frequency, again, it is given by this formula already deduced. And final point, The voltage escalation factor or quality factor is given by the same formula. So these are the different aspects of series resonant circuit and parallel resonant circuit. So with this, I am ending here. Just to recap that in this part we have discussed the series resonant circuit and parallel resonant circuit. In the series resonant circuit, we have found that impedance becomes minimum, so current becomes maximum. So it is sometimes called current acceptor circuit. For the parallel resonance circuit, impedance becomes maximum, so current becomes minimum. That is why sometimes it is called current rejection circuit. For both of the cases, we have power factor unity because net reactive part is 0. The fundamental conception of having resonance circuit is that net reactive component is 0. That is why power factor is always 1 in case of a resonance. Now, quality factor, we have also reduced the formula for quality factor and resonance frequency for series and parallel resonance circuit. So with this, I am ending here. So AC fundamental, the module 2 what we have discussed, that is module 2 AC fundamental is ended. This is the last topic of AC fundamental. From the next part of this course, that is module 3, that is 3-phase AC circuit, it will be discussed. So with this, I am ending here. Thank you.